All right. So today I'm going to give a discussion about what's called a dynamic array-based list. A dynamic array-based list is an array-based list just like the ones we've seen before, except when this array list is full and someone inserts into it, we will cause the array-based list to hold more items, so it will expand in size, and that way as we add items we will conceivably always have room. And so this is a more advanced feature in an array-based list. Knowing how to insert at and remove at are critical. You absolutely need to know how to do those. Other simple operations like printing the list, clearing the list, stuff like that, getting an item at a particular point in the list, those are all basic and really easy. But the insert at and remove at, you really have to know. So what happens when you insert at and the array is full? Well, let me set up this scenario. Let's assume in our tiny little array that we have more items in it, right? And that we are full. Size is now 5, which is also our capacity. So our list, our array is full. So if we want to insert, we still have the valid range of positions from 0 to size, right? But in this case, there's no room to shift anything out of the way. Some array-based lists, some specialized lists, are built with priority, which means that when you insert, new items have priority and they kick items out of the list that are in the list. This is kind of an interesting feature. We're not going to do that. What we want to do is we want to make this list big enough to hold all the items. So here's the problem. Once you put an array in RAM, it is fixed in size. It's fixed in size because you can't make it bigger. If you try to make it bigger, then there's stuff underneath that you will be wiping out, so you can't do that. You can't make it smaller because the memory manager will be a mess if you do that. It's way too hard to keep track of, so memory management programs don't allow you to do that. So basically, once you have put an array object in RAM, that's its size, period. So in order to make our list bigger, we have to make a new array that is also bigger. So what we will do is we create a new array. I made it wider accidentally. Let's make it slightly bigger. Actually, let's make it a lot bigger. Right, so now we have a bigger array, and what we do is we copy the items from here over here. And while we are doing that, we insert our new element where it goes, right? And so let's say we put the 2 and the 8 and the 10. Let's say we were inserting a 7 into place 3. We would put the 7 there, and then we would put the 6 and the 8, and then we would increment our size to 6, because now we have 6 elements, right? And then we get rid of this array. And now this is our array, and it's bigger. And now we can add more items, and they'll fit. And that's it. It's almost sleight of hand, right? You just kind of go, well, I'm putting things in this array list, and it just keeps taking them. It just keeps taking them. But under the hood, what is happening is you're filling up an array, and when it reaches capacity, Java instantiates a newer array that's bigger, dumps all the data in along with your item, right? And now you've got more room. And when that one fills up, it does it again, and it does it again, and it does it again, and you don't even know it. So when we make our dynamic array list, we want it to grow like this, and we want to do it in such a way that the people that are using the list don't even know that it's happening.